Hi folks, and welcome back to Math with Captain Rod. I'm making this video here to go through some examples of solving inequalities that have a little bit more going on to them. So we're going to take a look at a couple examples. Let's start with this one. So this 2x plus 3 absolute valued less than 7. Now, before we get into the weeds here and talk about the details, if you have the absolute value of something, that's what this is supposed to represent, doesn't matter what, less than 7, the something has to be bound between minus 7 and 7 because, take a look at this. Absolute value of 8, not less than 7. Absolute value of negative 8 is also not less than 7. So the solution here is a bound type of solution. Now, there's a couple different ways we can write this. We can either write it with a pair of inequalities. We could say that the something, whatever it is, has to be less than 7. See how it's to the left of the 7 here? And it also has to be greater than negative 7. So what we can do is write a pair of inequalities, and where these inequalities overlap is our solution. The other thing we can do, and it's probably a little shorter, I'm going to do this, is whatever this is, it has to be between negative 7 and 7. So I can write a single inequality statement that says that very easily. And it would look like this. Negative 7 less than 2x plus 3 less than 7. So this is a single statement here with two inequalities that says whatever this is, it has to be between negative 7 and 7. See how the greater than is like wanting to eat the 2x plus 3, meaning this is bigger than the minus 7, and over here the 7 is bigger. And now we'll just solve this inequality statement here. So these are solved just like all the others. We would start by subtracting 3 from everything. So this is now going to read negative 10 is less than 2x is less than, let's see, 7 minus 3, 4. Divide everything by 2, and this is going to read negative 5 less than x less than 2. So there's our solution here. X has to be bound between minus 5 and 2. This is one way to write our answer. It's perfectly acceptable. On a number line, I like these. Here's negative 5. 2 is over here. Open circle because these do not have equalities. Open circle, open circle. So there's another way to express our answer. We could also do it with a pair of inequalities here. Or actually, I'm sorry, set notation. Oh, one more time. Interval notation. That's what I was looking for. So our solution is from minus 5, not including minus 5, to 2, and not including the 2. So these are just three different ways of expressing the same answer. So there's that one. Let's take a look at the one on the right. All right, so 3x minus 1, absolute valued, has to be 11. Now for starters, let's talk about this 3x minus 1 here. I'm just going to call this little symbol here, just stands for something. If you have the absolute value of something greater than 11, and you look at what solves that, the something could be like 12 or 13 or 15. It could be negative 12 because absolute value of negative 12 is 12, which is in fact greater than 11. It could be negative 13, negative 15. What it can't be is anything in the middle here. Try it, like absolute value of 0 is not greater than 11. So when you get these greater thans, you get like a pair of sets types of solutions. So what we're going to do is we're going to write a couple of different inequalities here. Let's talk about this one right here. For starters, the 3x minus 1, could be over here somewhere, meaning less than negative 11. The other possibility, so I'm going to put or here, is that the 3x minus 1 could be, in this part of the solution region here. In other words, greater than 11. So when you have inequalities that are greater than, you get two possible sets of solutions here. Either one yields viable solutions. Now we'll just solve these independently. So we'll add the 1, and we're going to have 3x less than, let's see if we add 1, that's a negative 10. Then we'll divide by 3, so x less than minus 10 thirds. Take a look at what's going on over here. So 3x minus 1, let's see, greater than 11, so adding 1, this is going to be 3x greater than 12, dividing by 3, x greater than 4. All right, let's do my favorite, our number line stuff. So here's our minus 10/3. Open circle because there's no equality. This says less than, so arrow to the left. Anything in this region should solve the original. 4 is over here to the right somewhere. Doesn't matter exactly where we put it. Again, no equality, so open circle. This reads x greater than, so arrow to the right. In interval notation, this one, our solution is from negative 10/3 to the left, so we can write minus infinity, minus 10/3, open circle. You always just put an open one on this one to minus infinity. Now again, because there's no equality here, that's called an open circle, as opposed to if there was an equality, we would put this symbol. But there's not, so we'll get rid of that. Okay, the other set is from 4 to plus infinity. Again, not including the 4. Anything that solves this or this is part of the solution set, so we put this symbol between them. You could actually, if you're in my class and you just want to put or, I'm perfectly happy with it. That's what that symbol means. So there are a pair of inequalities with absolute values. I hope that this helps you understand how to solve these. Have a great day.